We are, believe it or not, finally on the last page of lesson 1.2. Now, because we're getting a late start, it's going to take me, obviously, today and tomorrow. The assignment you see up there, page 95, 48 through 66 evens, goes with this page of notes. Okay? So that I will teach on today, teach on tomorrow, which is Thursday. In a normal week, it would be due on Friday. But Friday, we won't be here. It's an e-learning day, so it will end up being due on Monday. Now, I am going to tell you it's not going to be your e-learning assignment, though. Okay? So you have something separate for e-learning. Okay. Even and odd functions and symmetry. Okay. So a function can be called even or odd, or neither, honestly. Okay. Functions that are considered even. Okay, note here, if a function is considered even, graphically, it is symmetric across the y-axis. So if you look at a graph, you can tell a function is even because it's symmetric across the y-axis, which means what? What do I mean when I say symmetric across the y-axis? Y-axis is our vertical axis, right? So that would mean it reflects left to right, right? Okay. Now, algebraically, a function is even if f of x equals f of negative x. So that is, if you just have the equations and you don't have the ability to look at the graph, we can look at them algebraically. And we're going to practice both, okay? Now, the other one we're going to talk about today, functions that are odd. If a function is odd, now don't go assuming here, it says it has origin symmetry. You might have been guessing x-axis, but no, it has origin symmetry. It is symmetric across the origin. So if it's symmetric across the origin, I'll show you an example, but it's kind of like a diagonal symmetry. An origin symmetry is if you reflect it across both axes. So like if you reflect it across the y-axis and then the x-axis, it ends up in that diagonal quadrant, right? And it also almost looks like a rotation, like a 180-degree rotation. Okay, so that's origin symmetry. Now, algebraically, if a function is odd, then f of negative x is equal to negative f of x. Okay, so these are all about the reflections here. So, I'm going to look at them algebraically first, and then we'll kind of confirm graphically. In all honesty, when it comes to, if I ask you, is this function even or odd? You can use either or. You can do the algebra, you can do the graph. Sometimes one is easier than the other, though, to tell, just depending on the situation. So, tell whether the functions are even, odd, or neither. Also determine their symmetry. Okay, so, we'll look at the graph here in a moment. Algebraically, here's f, the given is f of x, right? We need to find things like f of negative x and negative f of x. Okay? So, start by finding f of negative x. If I find f of negative x, we've talked about this before, every place I see an x, I'm going to replace it with negative x. Okay, so it was f of x, I want to make it f of negative x. Every place I see x, I'm replacing it with negative x. So the original equation is x squared. So it says to take x and square it. What am I going to square instead? I'm going to put negative in there. Negative x and square it. So I took x and I replaced it with negative x. Now what happens when I square negative x? It's positive again, isn't it? And so if we clean this up, negative x raised to the second becomes positive x squared, still minus 3. What do you notice here? What do we end up with? X squared minus 3, which was the original, wasn't it? So I just showed that f of x is equal to f of negative x. What does that mean according to our definitions up above? It's even. Okay, it's even. Now, you can stop there. Once you know that f of x and f of negative x are the same, you can stop. You don't have to keep going algebraically. What do you expect to see happen on the graph then? Okay, according to our directions, if it's even, it's symmetric across the y-axis. So, I've got x squared minus 3 typed in here, and I'm going to hit graph. X squared minus 3 is a parabola moved down 3. Is that symmetric across the y-axis? Yeah, if I take that graph and I fold that across the y-axis. Okay, so, in all honesty, did we have to do the algebra there? Technically, no, we didn't have to do the algebra. We could have just gone straight to the graph. Again, I want you to be able to do both because there's times that one is easier than the other. It always just depends on the problem. Okay, so I'm going to put a little sketch here. Nothing fancy, just showing that this is a parabola. And so to answer the other question, it says determine the symmetry. So I'm going to say symmetric across the y-axis. So I just showed you two reasons that it's even. F of x equals f of negative x, and symmetric across the y-axis. Waiting for people to show up. Okay, let's try B. I want to start algebraically because that's honestly, that's the one you guys are going to struggle with more. You can look at a graph better. Okay, so what's the first thing I'm going to do? They're giving me g of x, so I need to find g of negative x and see what happens. Okay, g of negative x says every place I see an x, I'm replacing it with negative x. So instead of raising x to the second, I'm going to say negative x to the second. Instead of minus 2 times x, it's minus 2 times negative x. And then minus 2. Okay. What is negative x raised to the second? Positive x squared. Minus 2 times negative x is going to become plus 2x, and then we still have a minus 2. Okay, so I just got x squared plus 2x minus 2. What do I know right now? Okay, it's positive 2x instead of negative 2x, so these are not the same, are they? So at this exact moment, I wouldn't say it's odd. I would say it's not even at this point. I don't know about odd yet. Does that make sense? So at this point, my brain is thinking, okay, I know it's not even. And the reason I say I don't know about odd yet is because technically a function doesn't have to be odd or even. It could be odd, even, or neither. Okay? So now, because that wasn't equal, g of x does not equal g of negative x. Now what am I going to try and find? We already checked what g of negative x is. I also need to find what negative g of x is. Negative g of x, because that negative is out front of the function, says multiply the whole function by a negative. So if I'm going to multiply the whole function by a negative, basically it's saying like take a negative and distribute it. We're going to distribute it to x squared. We're going to distribute it to minus 2x. And we're going to distribute it to minus 2. So basically when I distribute that negative to everything, it's going to change all the signs. Positive x squared plus 2x plus 2. Now, what am I trying to compare it to? I want to see if g of negative x and negative g of x are the same. That's what's going to tell me odd. So are g of negative x and negative g of x the same? Are these two the same? They're different by a sign, aren't they? I have minus 2 versus plus 2. So now what do I know? It's not odd. Because g of negative x and negative g of x were not equal. Well, if it's not even and it's not odd, guess what? It's neither. Now, real quick, let me show you the graph. Maybe. X to the second minus 2x minus 2. Notice it's a parabola again, right? And parabolas can be symmetric, but this parabola is off-center, isn't it? So because it's off-center, it's not symmetric across the y. If I try and flip that bottom of that parabola to a diagonal quadrant, it's not over there. So this one is neither. Okay? We will pick up with C tomorrow and talk about asymptotes and in behavior. You can go ahead and start looking at homework if you want. I don't know if you really know a whole lot to be able to do much. Okay?
Ethan Whitterow, please come to the high school office.
Odd will be symmetric across the origin, and I'll show an example.